Okay, so the next problem we're going to do is 11-20. Let me read out the problem to you. A hand-started motor is accelerated from rest to 150 RPM in 1 second when the rope is pulled. It then starts and under load accelerates uniformly to 3600 RPM in another 7 seconds. Determine A, the angular acceleration in each case, and B, the total number of revolutions of the motor. So this motor is, so it's a handheld, it's a hand-started motor. So first you yank the rope, and then from 0 it goes to 150 RPM in 1 second, right? Then the motor kicks in, and then it goes in the second stage, it goes from 150 RPM to 3600 RPM in 7 seconds. So there are two stages. One is the hand started part going from 0 to 150 RPM. Second is the motor kicks in and goes from 150 to 3600 in 7 seconds. In both cases we need to find the acceleration and then also the theta. Okay, so let's write the data down. So it starts from rest, so omega 0 is 0, and then omega is, it goes to 150 RPM. Of course we have to convert this, we'll do that later. And then this happens in 1 second. I'll call this T1, 1 second. This is the first stage 1. Let's call this stage 1, first stage. Second stage, okay, maybe I should change the color for second stage. Stage 2. Here omega 2, so here omega naught becomes the 150 RPM, and omega becomes, or the final velocity becomes 3600 RPM. Okay, and then this takes 7 seconds. I'm going to call it 2 just to differentiate. Maybe I should call this one also 2. Okay. All right. What else is given? That's all. That's the information that's given. Now let's go to this. Convert 150 RPM to radians, because everything else we're going to calculate in radians. All right. So 150 revs per minute times 1 minute is 60 seconds times rev, so 1 revolution is 2 pi radians. Okay, so we get 15.7 radians per second. Okay, so this is equal to, all right, so 15.7 radians per second. Same way here. So basically what we're doing is multiplying times 2 pi over 60. So that should come to close to 360. So that's actually 377 radians per second. So this is 377 radians per second. Okay, so these are what we're going to use. Now going back to case 1, stage 1, let's evaluate everything what we need. So they want us to calculate angular acceleration and the revolutions, so theta and angular acceleration. So when we have initial velocity, final velocity, and time, we use the simple formula, right? V equals u plus at, or omega 1 equals omega naught plus alpha t. Alpha equals omega 1 minus omega naught over, so call it T1. So this is what, 15.7 minus 0 divided by 1 second is 15.7 radians per second square. Okay. and then we calculate theta. So let's call this theta 1. S equals ut plus half a t square. Okay. Now omega naught is 0 times t, everything becomes 0. Half alpha we just calculated 15.7, t square is 1 square. Okay, so basically half of 15.7, which is equal to what would that be, 15, 2, so 2 times 7 is 14, 1, 2 times 8 is 16, and 5. Okay, 7.85. Please check my arithmetic is radians. Okay, all right. Now so we're done with the stage 1. For stage 2, again I'll change color so you can see it. All right, we follow the same thing for time. Final velocity, final minus initial divided by time. So t2 is final velocity minus initial velocity divided by time. So here let me call this W1. Okay, right. So W1. Okay, here also would be omega 1. Okay. So so omega 2, which is 377, minus omega 1, this is RPM, but 150 RPM we know is 15.7. So 377 minus 15.7 divided by 7 seconds. So 377 minus 15.7 divided by 7 seconds. So that comes to, alright, that comes to 51.61 radians per second squared. Alright, this problem is actually very simple. The only thing here is the final velocity of the first stage. The final velocity of the first stage becomes the initial velocity of the second stage. That's all there is. Otherwise it's the same problem, same steps from here to here. You're just having to repeat it again. Okay, all right. Sorry, this is not t2, this is alpha 2. Okay. Alpha 2 is 51.61 radians per second squared. Okay, now finding theta 2. Theta 2 is omega 1 t2 plus half acceleration times t2 squared. Okay, the subscripts are for your convenience. You know, if you don't write the subscripts right, but you put in the right numbers, you know, that's fine too, or you know, it can be overlooked. It should be proper, but sometimes if you mess up the subscripts, but again, if you put the substitutions right, then that's not a big crime. Okay. Initial velocity times the time is 7 seconds plus half a2 is 51.61 times t2, 7 squared. All right, so what does that come to? That is that comes to, okay, here it comes to 1374.3 radians. Okay, like I said, please check my arithmetic after me. Okay, now the total time is 1 second plus, now if there's what is asked, the total number of revolutions in the motor. So you know, so in the first stage plus second stage, so the first stage that 7.85, in the second stage 1374.3. so total revs, okay, is equal to theta 1 plus theta 2, that's equal to 7.85 plus 1374.3, so that is what does it come to? Okay, 5 and 5, 1, then 1, 8, 2, 8, 3, 1. Okay. So many radians. Okay, so many giving the answer in radians is kind of, like I said, not very intuitive. Let's convert this to revolutions. Okay, so 1382.15 radians is, you will say 2 pi radians here, because radians should cancel out, and that's equal to 1 revolution. So when you do that, 1382.15 divided by 2 pi, let's see how much that is. That comes to 220 revolutions. Okay, so basically in this two-stage motor, once you pull it by hand, it goes from 0 to 150 RPM in 1 second, and then the motor kicks in. It goes from 150 RPM to 3600 RPM in 7 seconds. So total 8 seconds of time until you from the moment you yank the cord, and in that time it has covered 220 revolutions.